3-2. We only have one lesson today. Notice there's a couple ways that we could start. The first way we're going to start is with a point. Okay, let's say I have the point 1, 5 and a slope of -3. Okay, so we have the point 1, 5 and a slope of 3. So last time we went ahead and wrote equations, didn't we? Or what did I give you? Slope and a y-intercept, correct? Slope and a y-intercept. Because remember, it was y equals mx plus b, which is in slope-intercept form, correct? But I don't give you a slope and an intercept, do I? I give you a slope and a point. So we can go ahead and do this, okay? So once again, here's 1, 5. Okay? My slope being what? -3, understanding that that's -3 over 1, right? Okay, -3 over 1. So I could go down 3, 1, 2, 3 over 1. Down 3, 1, 2, 3 over 1. Notice, or what else could I do? This is equivalent to who again? 3 over -1, correct? So I could rise 3, 1, 2, 3 over 1. Okay? Now the nice thing is what did I just find by graphing this? I graphed my y-intercept because I went rise over run and it went perfect to my y-intercept, which is 8, isn't it? Everybody see how I got 8? Do we want to do that? Because what if I give you the point that 100, 7? You guys want to go all the way over 100 tick marks to find your y-intercept? No, that's not how it works. So let's try and just finish this up with what we know. So we do know that our slope is -3x, and then our y-intercept was 8 because we plotted it and went and found it from there, correct? Okay, but not every single time is that going to be the best possible method. So the other way that's nice is what we call a slope-intercept. Not slope-intercept, point slope. I apologize. Point slope form. Okay, point slope form is y minus y1 equals your slope times x minus x1. Okay, that is point slope. I'm actually going to show you where that comes from in just a minute, but right now we're just going to take it for granted and just use it. Okay. What was the point that I gave you again? 1, 5, is that correct? Okay. So I had 1, 5 and my slope being -3. So understand all this is, ladies and gentlemen, he's my x1 and he's my y1. Now right there, it's just a plug and chug. Okay. So I plug it in, y minus y1, which is 5, equals my slope, which is -3, x minus x1, which is 1. Okay? I'll go ahead and distribute through. Sorry, that's an equal sign. So I have y minus 5 equals -3x plus 3. I add the 5 over. -3x plus 8. Now, if I'm given my slope and a y-intercept, obviously the other way is quicker, correct? But not every situation dictates that. So therefore, I put it into point slope. How many of you guys have ever used point slope? It might have been a while ago, but you should have used it. Now, some teachers, I always like to show a little bit of every way so you guys feel comfortable on maybe what you've learned in the past. Does that make sense? Some teachers always just use, once again, I had the point 1, 5, and the slope being -3, and they still just use slope-intercept. Okay, and here's what they do. They put the slope in. What is x? What's our x value? 1. What's our y value? 5. And the thing we don't know is our y-intercept, huh? Does that make sense to everybody, how that came about? So, and like I said, I don't care how you do it. I really don't. So whatever you feel the most comfortable doing, that works for me. Okay, so here we go. I get 5 equals -3 times 1 plus b. Monkeys are on the loose. Didn't that sound like a big gorilla or something? Orangutan? No? No? So doesn't b equal 8? So then I come back up here, y equals my slope. And notice I've got the same result 3 different ways, right? Now, number 1 way, always not the prettiest way. Kristen, you sit up here today, or are you good? I just need to switch it. All right. I have glasses issues. That's Mr. I don't remember his name. Human biology, 11th grade. That's when I knew I needed glasses. I would sat back over here, and I always had to sit up front. You have glasses, don't you? Yeah. You silly rabbit. You got 2 seats up here for today. If you just want to sit up there, one wrong. All right. I'll shut up then. Okay. Everybody good with that? Okay. Now, what is slope again? What's another thing that we learned about slope last time? Slope was what? Rise over run. Thank you for talking to me. Appreciate you talking. Rise over run. Okay. So I like to do sometimes rise over run via a graph. So let's go ahead and just take 2 points. Give me a point, Mr. Joseph. 2, 3. How about we do 2, -3, at least so we have a different way to go, okay? All right. All right. Oh. Tell me your name again. Chance. Standage. Something. Standage? I was way off. Okay. Can you give me another point? All right. Now, once again, you guys made this up, so blame yourselves, okay? If this goes wrong. So first off, we're going to write the equation, but I want you to just plot this and draft a line in between them, okay? So with that being said, Joseph said 2, 3, but I made him go to -3 just so we have a negative value to work with, right? And then we have 6. 8. Ah, frick. Thank you. Okay. So with that being said, I have a y-intercept. It looks like it's crossing at -1. Is it? It could be. But it's not very pretty, is it? Because I just hand did that, right? So it might not be. Now the reason why I was able to use my y-intercept last time is why? Because I actually rose and ran using coordinate points, correct? Does that make sense to everybody? That's why I was able to find my y-intercept, because I knew that's where it was, because I rose 3, ran 1, and I got exactly on my y-intercept, right? It looks like -1, but it doesn't necessarily have to be because this is a hand sketch, correct? Just want to clarify on that and make sure you guys understand. Okay. So I still want to write this equation. What do I need to do to write an equation, though, for a linear equation? I need a slope, don't I? Okay. So either A, I got 2 options. I can take this point, which was -6, 8. And I can take this point right here, which was 2, -3. And I can say, okay, how much did he rise? How much did he run? So I went from 8 all the way down to -3. How much is my rise? He went down 11, didn't he? You guys agree with that? How much did I run? I went from all the way from -6 all the way over to 2. I ran 8. Okay? So notice, what do I have now? What's my slope? Negative 11/8. By the way, when do you use such a formula when it's called point slope? When I got a point and a, oh my hell, told you right there. What a coinkydink. Okay? So knowing that, I had 2 points, but within any 2 points, what can I always find? Slope. I got slope and a point. I wonder what equation I'm going to use. Baffling to me. Okay? I'm going to use point slope, right? Or I could use what I just showed you with the y equals mx plus b, where you can solve. I don't care how you do it. Once again, just do it. Okay? I'm going to use point slope. Anytime I do it, I use point slope because that's what I was taught. So I guess that's kind of what I'm more comfortable with. But I'm just showing you it's not necessarily the only way. So I got y minus, wasn't it y1? Does it matter who I pick out of these 2 points? I'm going to pick this guy just for kicks and giggles. Okay? So I'm going to go y minus y1, which would be a negative 3, equals negative 11/8 parentheses x minus 2. Any questions on how I got there? Now this one's not as fun because these buckwheats gave me fractions. But it is what it is. Isn't fractions part of life and we're going to have to use them anyway? Sure. Okay? So understand this does become a plus, doesn't it? Because a negative is a positive. So I have y plus 3 equals, how do I multiply fractions? Straight across. Flip, skip, multiplies when you divide. Okay, so I'm going to come straight across. Negative 11/8 times that is negative 11/8 x. But negative 11 times negative 2, 22/8, right? Which we could also say that's 11/4. Does everybody understand how I got 11/4 out of that by reducing by 2? Any questions there? Yes, no, maybe so? Okay. But the thing is I don't have y by himself, do I? So how do I get him to the other side? Subtract 3, which is the same thing as subtracting what? 12/4. What 12 divided by 4? I just got a common denominator, didn't I? When I add subtractor, when I add or subtract fractions, I need a common denominator. I think of Arnold Schwarzenegger. I do because he's the third name. I just always think of Arnold doing all these fractions. I don't know why, but I do. This is what it is. So y equals negative 11/8. 11/4 minus 12/4 is x minus 1/4. I thought it was negative 1. It's really negative 1/4. That's why I really can't go off of what I always see unless I perfectly run myself and rise myself using slope onto that axis, right? Does that make sense to everybody? How was that? Is that hard? What can we always find with 2 points? Always what we can find. Slope, right? You can always find slope. Okay? After that, you always have 2 points. You can always find slope. If you can find slope and you have a point, what are we going to do? Write it in slope-intercept by doing point-slope form. Correct? Okay. Onward. You ready to onward? On a E? You good? Want a leg wrestle? I can't believe you wouldn't even say that. Sure. Here's my 2 points. Once again, with 2 points, what can I find? Slope. So last time we used rise over run, correct? This time, though, I'm going to use the equation. Does anybody remember what the equation is of slope? Well, let's talk about those people that have used chemistry or physics before. Anybody tell me what that triangle means? The change in y's over our change of x's. And that makes sense because isn't our rise telling us how much are we changing in our y values? And our run is how much are we changing in our x's, correct? And really the formula of that is y2 minus y1 over x2 minus x1. And that makes sense. The difference between those 2 points is your change. If I went from 5 to 8, 8 minus 5 is 3, hence our change is 3 units, right? Yes, no, maybe so. Okay, but notice, ladies and gentlemen, this is equal to slope. I wonder where point slope came from. You guys ready? Times that stuff over to the other side. Isn't that basically like point slope? Point slope came from just the slope equation. Okay, makes sense? All right, so let's go ahead and find our slope first. So I'm going to use this data right here. I'm going to call him x1. So if I call him x1, what's this guy? y1. The key thing about naming points, I could have called him x1, but if I called him x1, he's y1. If I called him x1, what's this guy? x2. The key thing is being the second value and the second value there as well. Right? Okay, so here we go. Let's do it. y2 minus y1 over x2 minus x1, which is 0 over 5. Sorry, I was a big door on that side. Does that make sense what I did there, though? Just plug it in. How much did I rise? None. How much did I run? So what's my slope? We talked about this last time. Remember, our slope would be 0. Okay? Hey, you! Did you notice how good I was? I got everything done. And it was the test.
What do you mean? Oh, you got all that done.
It's printing.
Oh,
It should be
you're
done.
awesome.
Yes,
Yeah,
I know.
that
Thanks.
is awesome.
Thanks for the pat on my back. Sometimes I need that. So can we put that into point slope still? What was one of my points? 3, 5? Was that one of them? And my slope this time is 0. So I go y minus 5 equals 0 times x minus 3. But what is 0 times anything? Sorry about that, Bush. You okay with that? Then we add the 5 over. Just y equals 5. Looks like a horizontal line, doesn't it? Right? Should it look like a horizontal line? Because my slope is not rising, but we are running, right? What would this one give us as a slope? X equals, notice our slope would be what? Would it be 0? It would be undefined. And you'll notice that because the fact of the matter, let's say you had the point 2, 3 and 2, negative 8. Right? Notice you should be able to see that they're the same x's, right? So you could just say, oh, this is x equals. Okay. Even if I did this, watch. Negative 8 minus 3 over 2 minus 2 is negative 11 over 0, which is undefined, and we should do this. That's your question. Any questions so far, guys? We're almost done. Got one example. You guys go over your book for me or your packet. Everybody have the packet, correct? Everybody asked them last time if you get a packet? I'd like you to go to 3-2, number 20. 3-2, number 20. 3-2, number 20. So this time, instead of me just talking to it up here and having all the information, I'm going to have you guys look at it. So the first part says blah 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 yakety schmack. This talks about how many community colleges are in the U.S. at any given time. 20. Tip rate on the top. Okay. So part A says plot the ordered pairs on the graph. Now, 1920. Do I really want to start at 0 all the way over here and go, oh, we're going by 100, 10, all the way over to 1900? Do we want to do that? What's a better way to do it? Do we have an idea? What do you think, Tyler? I could do the blip in the line. I could. Or, anybody else? I could just say 1920 is 0. What would be 1930? 10 years apart. Right? So, we're going to say that. I put that on my key. So, from now on, 1920 is 0. So, 1930 is 10, 20, 30, 40, 50, 60, 70. I think that's as far as I need to go because 1990 is 70 years away from 1920. Am I correct? So that would be representing 1990, which is 70 years away. Everybody see how I did that? So I just dictated it. Now, when I write this equation, what would I put in if I said 19, it was 20, right? Okay. So what if I said 1925? What would be my year? 5 years, right? 5 away from 1922. So 5 is my equation, not 1925. Does that make sense what I'm going for? Okay. Man, you're on your phone a lot. Yeah, I probably should just build it because you don't want to be here. Just get the hell out of here. You choose. But I think that's pretty rude. So, with that being said, how high does it go? You guys want to go by ticks of 1 or even 10? What's a realistic for you? Hundreds would probably be good. This is 1300. I know I kind of got a little bit there. This is 100. This is 500. This is 1,000. Okay. Any questions? You ready to plot? What's 1990? 1920, excuse me. It said it was 70. Am I right? I think I can remember that one. Okay, what about 1930? 178. 1940. What? 258? 1940. 337. Okay. 1950. Did we already do that one? Oh, so that's 20. Sorry, 60. 1960. 390, so a little bit higher. Okay. Then 1970, it really like skyrockets, doesn't it? Where does it go to? 847. So we're all the way up to here. All of a sudden, that was pretty linear. You guys agree? But all of a sudden, vroom, we just kicked butt and took names. 1980. 1,000 what? 49, and then it was like 1278 or something like that, right? Okay. So if I graph that from year to year, that's what it looks like. And to be honest with you, we have two pretty good linear equations. From there on, it looks pretty linear up there, doesn't it? And on the bottom looks pretty linear. Let's set that year. What do you guys think the reason was? Was it 1960, 1970? That was the year that they jumped. What do you guys think that could have been? Beforehand? How many people even graduated high school? Let alone go to community college, right? And maybe a little older. My parents, I remember when they got to high school, most people were like a high school diploma was what our degree of college is nowadays. Really, like if you were at a high school diploma, you were like 2K for my parents, right? And nowadays it's like really just a high school diploma type of deal. Let's be honest, right? Okay. So maybe at that time, that's when education maybe started increasing a little bit more, meaning, hey, let's take advantage of this a little bit better, and so therefore they might be. That could be the reasoning, but overall, this really isn't too linear from the years that we have. Now, if we did it in separate increments, I can see it. This is linear, pretty linear, and so is this guy, right? But the other part, that one makes that big jump. Okay, so let's go through it. Part A, what does it say there, Joseph? Part A, we just plotted. Part B.
Compute and interpret the average
All right, let's 1920 to 1930. And sometimes, if you're already in a chart, I go like such. What was the amount in 1920? Was it 70? How about 1930? Okay, so average rate of change. Does anybody know what that is? Slope. So write that in your notes. Average rate of change is just slope. Average rate of change is just slope. So, once again, this is basically our x, this is basically our y, because we talked about independent and dependent variables last time, right? Does the year dictate the schools, or does the school dictate the year? The year dictates how many schools there are, right? So this is our independent, hence the x. This is our dependent, hence the y. Okay? So remember, average rate of change is just saying basically rise over run, or the change of your y's over the change of your x's for the dictating part. Now what if I had 1990 really quick? What was that amount again? 1282? 1282. Okay, so for part A, they ask us to find the average rate of change between these two years. Correct? So how much did I just go? I went up how much? I went up 108 schools in that 10 years, didn't I? You guys agree with me? So what's my slope? 108 divided by 10 equals 10.8. What does that represent? What does 10.8 represent? That's what it means by interpret the data. We're increasing 10.8 schools per year in that decade, right? Okay, what if they said average rate of change between 1920 and 1990? How would I do that? I'd say, oh, how much is it from here to here, right? From here to here, right? And I'd say, oh, that is 1,212. So 1,212 divided by how much? 70. So somebody do that for me. 1,212 divided by 70. Okay, 17.31. So, and as we talked about, you notice we had 1,017, say again. Are they the same slope? Well, we already kind of see that they weren't going to have the same slope because we looked at it, right, and it didn't look linear. But that also gives you a reasoning it's not linear. Because at first we're increasing by this. Next we're increasing by this. What happened if the first all years were like 10.8, 10.4, 10.6? Is that perfect data to be linear? Is it perfect data? No, but pretty much couldn't we say that it's linear in a way? Because it's really kind of off just a little bit, but in general, it's working, right? To understand, sometimes your data is not going to be right on in a real world problem. But does it have similarities to a linear equation? Sure. But 10.8 to 17, that's too much to really say that it's the same constant rate of change, right? Or average rate of change. A little too much. So you really couldn't say that. Okay? What part B say? An average rate of change again?
Yeah.
So we already don't have to do that, I don't need to do that again, do I? And then I think it says do it one more time, and it says interpret the data and say, is this really a linear model? And we could say once again, not really, because the slopes aren't or even close. Okay. Now if they're 10.6, like I said, 10.4, 10.8, I'd go with it. Okay? Can't tell you. I don't know what it is. Okay.
If it was like 10 to 8,
I would say if it said it say is this pretty linearly, I would say yes. And just for the fact of the matter, now obviously I want you to discuss it, it's not just a yes, right? They're gonna probably ask you why. Well, once again, in terms of real world data, we're pretty much right around 10.6 away. I would say that. Okay, look at that, guys. We got a half hour. I'm going to tell you what you're going to do today. You ready? You're on just 3-2. That's the only one we're doing today, 3-2. So you're going to do all the odds with 3-2, but I'm going to assign a few extras to you. Okay? So those few extras are going to be number 24, please. Please. 38, please. So odds and then those 3 extra numbers. Okay? 30 minutes, you guys can work on anything you so choose. If you choose to sit here, that's what you choose to do. You know what I mean? So it's your time. You can do whatever you so choose. Okay.